Good afternoon, everyone. In this talk, I want to tell you about how I use TensorFlow, and I will tell you how I did 3 different projects for that. So this is a CAPTCHA screen. Probably all of you are familiar with this, right? You put the code, you type whatever it says in the CAPTCHA, and then you can log in. And earlier, and last year, I helped organize an online software and security challenge, which is called Blacklight. It is completely open source for everyone, and you should go there and give it a try. You can practice your coding skills, you can practice your security skills. What I was doing mainly in that challenge is kind of a proof of concept, which means here's a challenge, try it, tell me if you think it's reasonable to solve during a conference. So what we did, we would take this challenge to conferences like this one, and then participants who didn't feel like being in the talk would just go and try to hack while using this website. And so one of the challenges was trying to break into this interface. So we all know how this works, right? Brute force. You try all the combinations from 0000, 0001, 0002, all the way to 9999. And you write some kind of a software, and you broke into the system, right? All done that? Everybody here are hackers. But we have this CAPTCHA. And the CAPTCHA is getting in your way of manually typing 0000, and then, like, what is it, YALZ63, 5050, I will fail this myself. So we figured it's a fun time to try TensorFlow. Because you can write a simple software that says, go in this field and type something, but you need something smart that will go in this field, and then will say, this looks like a Y, and this looks like an A, and so on, right? And when you have a model that is trained on this, you can give this picture to the model, and the model will give you back a string that says YALZ63. And this way, you can completely automate your breaking into the system, right? Make sense so far? Yeah. And so in this challenge, in the specific challenge that it was in that specific conference, one of the things you got as a reward from your previous stage, from a previous challenge that you hacked, was actually the model itself. So it was pretty much just using the software that you have to consume the image and translate it into a string. And so here are the steps that I did in cracking this. Step 1 was inspect the model. In TensorFlow slang, it means tell me about the model, how many inputs, how many outputs, what is the format, is it a string, is it an integer, things like that. After inspect it, we're going to load it into the code. So you know how you sometimes load some kind of a library when you write a code? Similar way, you just load the model. And then brute force. So in case we're going to make one time a wrong CAPTCHA translation, because models are not 100% right, we want to keep the session of the attempt to log in running, because let's say I am now in 1227, but my picture translated this to YBLZ63, right? Because we make mistakes, computer make mistakes. So I want to make sure my counter doesn't try the next time with 1228, because it could be that 1227 is the right code. So I'm telling open a cookie jar, keep it open until my session is complete. Then I'm getting the CAPTCHA image, so save the image. Predict the CAPTCHA using machine learning. So I'm talking to the TensorFlow API and says, here's my image, tell me what is the text. And then just guess the combination of the pin and the CAPTCHA. And you know, if we failed with a CAPTCHA, it's fine. Our session is open, so we can iterate with the same pin code. And this is a real picture from that conference, from the security camera in the room. Once you broke in to that interface, this is the next thing that you saw. It's a pretty cool thing. You have here a robotic arm, and then you had to move it with some kind of an API that eventually would make it push the door. And that's your next step in the challenge. But no spoilers, go to Blacklight, you can see more cool stuff there. The entire code that I wrote in Go, to do this, you can see here, or you can read in the link above. So that the link above describes the steps that I just told you in more detail, and just the pure code is the bolded one. But I'm not a data scientist. I'm not machine learning. Don't know what Nino told you about me, I can guess, but I'm a software engineer. I studied computer engineering, I was doing chip design in Intel, and I spent the last 4 years writing Go, and now I'm a DevOps person, so not machine learning. But this is me as a Gopher. So the Go community has the Go mascot, and everybody can get their personalized Gopher, and I am a Jedi. Thank you. Still, with all my only software, no machine learning experience, I managed to do this nice thing with a Go code, with a model that was given to me using the TensorFlow API, and this is what I'm telling you about today. You don't need only Python to do machine learning, even though this is something you probably hear together quite a lot, data science or machine learning with Python. Even if your code base at work is not written in Python, you can use any other API of machine learning to do TensorFlow. Let's talk about the steps of how to machine learn. Step one, we're going to define the problem. What is exactly the problem? What do we want to solve? Right? Do we want to translate a handwriting? Do we want to recognize a picture of somebody? Do we want to recognize if this is hot dog, not hot dog? We want to say, what's our success time? Right? Is it important for us to have 99.9% of accuracy, or is it important for us that maybe we can have up to 97%, but it has to happen in under 10 milliseconds? Different systems have different requirements. Next step, we gather the data. The data needs to be correct. Let's say I want to build myself a system that I can read Georgian with, because obviously I cannot. My data set will be all kinds of Georgian characters. If it's something mixed like here, that it shows some Georgian, some English, it's not good, because I don't want to train my model with English letters if I want my model to teach Georgian, right? I'm going to prepare my data once I have it. So I'm going to clean it. For example, I'm going to make sure that's in the middle. Every picture of a character is not that the character is in the corner, but it's standardized in the middle. I'm going to randomize it. You know, if it's going to be A, B, C, D, E all the time, then my model would know that if the last character was C, next one's going to be D. But that's not always true. And we're going to split the data. 75% of it will be used for training. 25% of it will be used for testing. And then comes the really hard choice of choosing a model. This is why many times you need a data scientist. They take in consideration all kinds of properties. For example, how many learning tasks are there? Learning task is your potential outcome, right? So we said hot dog, not hot dog, it's 2 potential. Digits, it's 10 potential outcomes. Faces can be billions. And then once we prepare the data and chose the model, we're going to train it. And we're going to assign random values, make iterations using our 75% data, and see if the prediction is correct. We're going to correct the values that we assign to our model, and we're going to make iterations until the precision is good enough. And once it's good enough, we're going to take the 25% of the data that's left, and we're going to test. If it's good, we're going to continue to tuning the hyperparameters, which is done manually, unlike the step before, step 6, where we tune the parameters with an automated script. So next step is doing it manually, and then we predict, we're ready to go. One of the tools with which you can do what I just described is TensorFlow. The definition of it, as I took from Wikipedia, is an open source software for machine intelligence, used mainly for machine learning applications such as neural networks. Also good for solving partial differential equations. This is a tensor. Tensor is a mathematical unit. It's a representation of something that can be of 2nd, 3rd, or 10th dimension, so not always easy to put in a picture. But you can describe it with 2 things. Those in the back that don't see, you can describe the type, integer, string, something else, and the shape. How many dimensions, how many values per dimension. And this is what our tensor flows through. That's the graph. So our tensor flows through the graph. The graph has the different nodes. Each node is the the operation that is happening on it at a specific point. So we have some kind of a mathematical value, and it has 3 fields, right? First, second, and third goes in here. Step 1, apply mathematical manipulation on it. Now it has a different value. This one has a different value, and this one. Step 2, again, we apply more mathematical manipulations. In the end, we get our output. This is essentially what is happening in TensorFlow. At any point of the graph, you can stop and look, what is my intermediate calculation? So not what's the result of my calculation, but what's right now the result. And what I really like about TensorFlow is that it's community-driven, and it's becoming really friendly for developers, right? Those people that are less good with machine learning or with data science, like myself. AutoML is a tool that automates the entire model's design, so it drops you immediately after step 7. Pretty much all you do in AutoML, you drag and drop pictures. You put into the pictures the tag. So let's say I'm putting pictures of all the Georgian characters, and I'm writing kind of the English sound of them, for example. This would be the tag, and that's it. In the end, I have a model. Another tool is called TensorFlow Hub, which is a repo of modules, right? Let's say some kind of a PhD student who just finished his thesis in machine learning. This is where they're going to put the model that they built in TensorFlow Hub, which is a repo on GitHub. This puts you at around step 5, so you already have ready models. All you have to do is train them. The third option is ready out-of-the-box tools, like Machinebox, which I really like, which are completely require you to do no coding at all. You just drag and drop your pictures or strings or any input, and what is the output that's expected, and you have a model that is already knowing how to do everything. And those are the languages that are supported, right? So we said, let's say I like working with Go, so if my company's code base is completely Go, not a problem, I can use that API. Let's say I'm doing some kind of an app, my entire code base is in Swift, not a problem. That exists, and there's even a TensorFlow Lite, which is more efficient for small devices. Let's say you're using Ruby or Scala. You don't have the full API, you do have bindings. So the point of the slide is that TensorFlow is actually open for many different types of languages, not just Python. Things you can do with a Go API is train the model and serve the model. So use the values, give them a picture and say, what is the value? What you cannot do with the Go API is build a model. For building a model, you need a Python person who writes Python. You probably also need a data scientist. It's pretty complex. In my last job, we decided that we're going to give TensorFlow a try because we wanted to build our in-house face recognition model. And the company that I worked for was called Grey Meta, and it's a platform for processing digital media and creating rich insights, injecting machine learning and human-generated metadata to make data fully searchable. This means, for example, the client was National Geographic. You know how they have lots of pictures, lots of articles, lots of videos, whatnot. They put all the data into the cloud connected to our platform. The platform starts processing it. And then whenever I write monkey eating peanuts, it finds to me all the images and all the videos of that without having to do actually anything. So it's like a smart way to search through lots of data. So you can see how TensorFlow sounded pretty cool for us. So we put these definitions, right? We said step 1 in machine learning, define everything you need. So we want thousands of categories. Remember, categories is the potential outcome. In this case, it's faces. Wants lots of faces of celebrities. We want to have an increasing number of categories, right? Every day, more and more people become famous. We want to be able to recognize everyone. We want to add many categories at the same time. So let's say finish the TV show of some kind of reality. Now all the 10 competitors become famous. We want to be able to recognize all 10 of them in one time. We don't want to add this face, next day another face, and another face, and another face. And we want to do this real time, and we want to have fast predictions. And so the steps we took, remember, are 8 steps. We gathered our data, and then we made sure it's a mix of private and open data sets. Open data sets is anything you can find online of what a human face looks like. Our private data set was really my colleagues. Just use lots of pictures of everyone. And then we prepared the data, so clean up, put them in the center, make sure it's the same white balance, and then we choose a model. Those were the 3 top competitors that we had, and we decided to go for FaceNet by Google because that was the one that we managed to reproduce the results when we tried manually. We tried OpenFace by Facebook. We could not reach the same % success recognition that they wrote, and all the other options were too esoteric. And then we built a classifier on top of the output. So let's say we one time put a face of somebody, we know who's that, it's already added to the data set kind of immediately. And then we wrote everything to be incorporated in our Go code base. The steps of evaluating the model, tune the parameters, and predict happened after I left, so never know if it will go successfully or not, but that was a fun adventure. And from building just with the FaceNet, with an open data set of 6,000 faces, we added 3 of my colleagues. So that's first group of the same colleague of mine, second group of that one colleague of mine, and a third group. So those are 3 different people. And based on putting one picture of each one of them, it then recognized pretty successfully the faces, just when I was still there, and that was before the iterations. So from one picture of somebody's face, the model already knows 80% of the times to recognize it. Pretty cool, right? Do some iterations, you're going to get better numbers. And that was the full stack of it. So we had everything, of course, Docker containerized, and all the key value pairs of picture name we stored in Redis. The third project I want to tell you about is called PhotoPrism, and I personally really like it because it comes from the Go meetup in Berlin, which I'm running for the 4th year, also a GDG chapter, just like here in Tbilisi. And one of the members came to me one day and said, you know, I built this app that's called PhotoPrism using TensorFlow because I wanted to try it. And what the app does is you put all your pictures there, and then you're just able to smart search in them. So you can search by location, for example, all the pictures that I took when I was in the US, or all the pictures that I took with my iPhone, or all the pictures that I recently imported is pretty easy, but let's say all the pictures that have buildings. And that's just like a fun app that somebody who's also not a data scientist, but just a software developer, built just using the Go API. So pretty cool, give it a try. And with my hope that you did get convinced and you think TensorFlow is cool and pretty approachable, this is the best picture for you to take from this presentation, all the sources. So we talked about AutoML, where you just drag and drop pictures. That's the link to it. We talked about TensorFlow Hub, which is the repo where all the models are located, and just some other resources, again, in GitHub. And thank you very much.